This is Natasha from NextWork here. I hope you can hear me okay. I hope you can see me okay. If you can, please give me a wave in the chat. It is so exciting to be doing another AWS project with you all this week. I feel like this has really started to become my highlight of every single week, being live in this chat room with you, doing a project together, solving some problems together. It's always so much fun. And today we are going to be doing a new project in the AWS networking series. For now, a big shout out to everyone that's already in the room. Oh my goodness. We have Abdul saying, I have the front seat. Yes, you do. A big shout out to you, Abdul. Henry says, I have taken the second seat in front. Can't wait. We have Aksha saying, waiting. The wait is over now. Thank you so much for waiting. We have Dari saying, hello, everyone. Hello, Nat. Super cool. It always makes me laugh to see Dari say super cool. So hi again, Dari. I hope the weather's really good over in KL. We have Fubara saying, let's go. Let's get these instances talking to each other. That's exactly what we're going to be doing today. And Linda says, hi, y'all. Akil says, hey, Akil, welcome to a live. It's so good to see you. Akil has been absolutely crushing it in the community lately, posting projects every single day. We see you, Akil, and it's good to see you in this live too. We have also B saying, super excited. Same here. Very, very cool project topic today. We have so much to cover. We have so many new learnings. This has honestly been my favorite project in the entire series, and I think it's going to be yours too, I think. Dari says, make Dari run into more errors. I hope you're ready, Dari, because there's going to be at least 2 errors in today's project. That was a bit of a teaser for you. But yes, shall we get started? As with every single project, you will see the classic setup of having our step-by-step guide or the AWS console on the left-hand side of my screen here. And on the right-hand side, you will see the step-by-step guide. So the AWS console, or yeah, I would say just the AWS console. We used to have the documentation template on the left-hand side of my screen as well, but actually, as of last week, we don't have a documentation template on a separate tab now. We will answer questions and create documentation as we go within the project guide on the right-hand side of my screen, which you're going to see in action. So this is going to be really fun. All right, so the project step-by-step guide, if you don't have access to that already, you can find it in the link in the description box. And all you have to do is, if you're in the community, just click on Start Your Project here as well, and then you're going to get taken straight to the project step-by-step guide too. The best setup, in my opinion, is to make the main part of your screen your AWS console, and you can see that I have the AWS console right in front of me now as well. Now, today's project is called Testing VPC Connectivity. This is project 5 of our networking series. So we have done 4 projects already. Do you see how cool your diagram looks? You've created that. If you've made it to this project and you've done the first 4, you have already created everything it takes, done everything it takes to set up everything in this architecture diagram here. What this architecture diagram is made out of, it's made out of your VPC, this pink area here, amazing. You have a public subnet, which is this smaller blue box in this area here. This is called your public subnet. Woo! You have an internet gateway. Go you for creating that, your internet gateway, right over here. You also have a route table over here, so good. Your security group, say what? When, the security group is the thing that's surrounding that orange box here that's within your public subnet. You have a private route table. You also have a private subnet. You have a network ACL. A network ACL is this thing here. Your private subnet, which is like this blue box here. Your private security group, this upper orange box. Your private network ACL, private route table. My goodness. Look at you go. You've already created so many things. You've even launched EC2 instances so that these are the instances that's within the orange boxes. What? We've created a lot of things already, haven't we? Aksha says, This is my first project. Is it good to attend this one? Yes, absolutely. You can still follow along. You don't need to do the first 4 projects to do this one. The step-by-step guide can still take you from absolute zero experience to getting everything done. It's just that doing the first 4 projects will give you a lot more context around the purpose of these different components within a VPC, within a network. So this project isn't going to go into details in explaining what is a VPC, what is a subnet, what's an internet gateway. The first 4 projects do that. And this project will just continue building on top of everything that we've done so far. So Akshay, you're absolutely welcome. I love to have you stay here and continue doing this project with us. Okay, now that we have the first 4 projects done, we are leveling up in today's project. This is really cool. We're going to test our VPC's connectivity. So you'll learn all about this in a minute, but connectivity, in short, is really just testing whether components in our network can talk to each other, whether the resources we've launched into the network can communicate with each other. So in today's project, we're going to get ready to do 3 things. First one is to connect to your public server from the AWS Management Console. That's the first connection. That's the first thing that's the first talking that we're going to do. Connect to your public server from the AWS Management Console means our first connection is from you. Technically, you're coming in through the Management Console, so you're actually from the public internet. You're going from here all the way to your public server. How are we going to talk? How are we going to get through all of these hurdles to talk to our public server? You're going to find out. Second thing, how can we get our EC2 instances to talk to each other? So now we're going to test connectivity between the EC2 instances. Oh, I love this one so much. We have our public and our private servers, right? We've launched them, one in a public subnet, a second one in the private subnet. How can these 2 talk to each other and be connected to each other? We're going to find out as well. And then the third one is how we can test VPC connectivity with the internet. So you know how in number 1, we're kind of looking at how we as a user can go talk to our public server. Number 3, this part is the other way around. So how can we go from the public server out to the internet? So that's pretty much like flipped. And that part is a lot of fun too. So we have 3 very cool things to tick off. And I can't wait to get started. So cool to have everyone in the chat as well. Abhishek says hello, Natasha, saying hello to you back, Abhishek. We also have Jerome saying hello. Hello, Jerome. Vivian says excited to learn today. Vivian, I'm very excited that you're excited too. Henry says, I prefer the documentation template. It gives one control over the design of the document. The PDF ends up scattering your pictures uploaded. Ooh, very good feedback. Thanks, Henry. So Henry's referring to the fact that we have recently upgraded our project app, or this web app that you see with the project step-by-step guide, to generate your documentation for you. Absolutely. We have noticed that the way the automatically generated documentation can scatter images, or it can end up looking a bit like broken up for some people, and we're absolutely working on that too. So we're working on a lot of ways that you can customize the look of your documentation, as well as have a very, very beautifully formatted documentation as a result of after creating this project with us. So we're definitely working on that too. Thank you so much, Henry. It's really cool to see that you've tried the old documentation templates and also trying the new ones too. Dylan says, happy to be here. Let's go. Thanks, Dylan. Wendy says, my usos. Usos? That's cool. Well, I wonder what usos means. You're going to have to teach me, Wendy. Pratik says, hello, Natasha. Maximus says, woo, go Nat. Pratik says, great initiative. My first live? It is, actually. I was going to say, I think it's my first time seeing the name Pratik in here. It might be one of my first times seeing Vivian as well, actually, now that we're talking about this. Shrida says, I'm excited to learn new things. Abbas, oh, so good to see you here again. Abbas says, let's go. Thank you so much, everyone. Look at all of this energy. We're all here to learn. We're all here to upskill in AWS and learn about cloud networking. This is such a good project to be doing that. So, okay, without further ado, Let's jump straight into it. So I'm going to click on the high touch guide as always, which gives us a step-by-step instructions. If you're feeling adventurous, if you're feeling like I can do a few things on my own, click on the low touch guide instead. That's option number 1. Now, as I mentioned before, today we're going to be getting our documentation generated for us automatically. And documentation is so important because it is the key piece of evidence about all of the learnings that you've had in this project. It is also a great place for you to store all of your screenshots and write all of the learnings. The one thing that we'll have to make sure we do to see that automatically generated documentation at the end is to make sure we fill out all of the tasks in this project so that we can get the right documentation. So I'll be demoing what the tasks look like and how to fill those out. But absolutely, if you have any questions at any time, add it to the chat, add it to the comment section, ask it in the community. We're all here to learn together. And questions absolutely make the experience even better. Joe says, "Woo, I'm not late." Joe, that's awesome. Welcome, Joe. Just in time for us to talk about step 1, which is to set up our VPC basics. So we're going to dive straight into where we left off in the last project. Now, if this is your very first project, if you're like Aksha, you can still do this project from scratch. And that's because the first 4 projects, every single time we finish that project, we delete all of the resources. And then at the start of every project, like the start of this one, we redo everything that we've done in the first few parts. And every time we redo it, it is super, super fast for us to redo, especially for this project, actually. Because in this project, we're going to use a shortcut method or a special method that we learned in the last project that helps us save a lot of time when it comes to repeating our steps and setting up the VPC from scratch again. Now, that shortcut is called the VPC wizard. And we would have learned that in the last part of Project 4. It is so easy to pick up from it from scratch. If you haven't used it before, let's do that now. So the VPC wizard is something that you can find in your VPC console. And that wizard is basically going to help us set up this structure that you see here in this diagram in minutes. Instead of like tens of minutes, it's now in the single digits now, I promise. So log into your AWS account. You can get the shortcut link to that in the project guide. But once you're logged in, you have this magical dashboard that I have in front of me right now. And we'll visit the search bar, that beautiful search bar at the top, and type in VPC to visit the VPC console. So we're going to click on VPC here. And from the left-hand navigation bar, you will see that the first option is your VPC. So let's click on that. And then we're going to click on Create VPC. Wow, in the meantime, B says, I wonder at the end if you can explain if there's any caveats while doing cross-region peering in the architecture. Means if private server is in another region. Thank you so much, B. This is a really, really good question. Cross-region peering, I wish I could say all of it now, but that's actually saved for a future project. If we were to go into that right now, our project might extend to a little bit longer than the scope of this one. So if you don't mind waiting for one of the future projects in the next few weeks, you'll be able to get that very, very soon. Lauren says, let's go, Nat. Belated happy birthday again. Thank you, Lawrence. Thank you so much. Wow, this is so sweet. And let's go, Lawrence. It's so good to see you in the live. It's nice to see you here again. So once we're in the VPC setup page, you will see that there's 2 options for you to create resources. One option is to create VPC only. We're not going to do that. We're going to click on VPC and more because this option lets you set up not just the VPC. The VPC is that pink area that you see here. It's going to let you set up a lot of the other components in this architecture diagram at the same time. So click on VPC and more, and you will see that once you click on VPC and more, there's already a diagram or resource map that shows up that actually tells you these are all of the resources this one flow can set up for you right away. And this resource map is just so cool to see because you can hover over it and then you can start to see connections between the different components as well. So for example, we have our VPC, we have subnets, route tables, and network connections, all of that set up in the same flow. Now, we're going to set up a very, very simple VPC. So we don't need to have so many subnets and route tables, so we can configure that and make that even simpler. Aksha also asked, can we create now and delete later? Absolutely, you can. So you can absolutely create now and delete later. Keeps the project free for you, and you don't get charged at all. Um, cool. But when it comes to setting up our resources, we're gonna make sure all of our resources have a very, very consistent name. So that's what the name tag auto generation is for. Under this name tag auto generation section, we're gonna type in NextWork like this. And then you will see that this is already updated for, again, this resource map that previews all of the resources you're going to make within this flow. Look at that. My VPC already has NextWork-VPC. My subnets are already named with NextWork at the start, so it all looks really consistent already. And then next is the CIDR block for your VPC. So we've already learned before that a CIDR block is pretty much a bulk or a block of addresses that get assigned to your network. So out of all of the resources that you can deploy or launch into your network, all of those resources will have an IP address that falls within the CIDR block that you define here. So it's kind of like saying when you're creating a VPC, you're creating like your very own city within a huge country, and the range of addresses that your city will have, or pretty much like the boundary of your city, is your CIDR block. The CIDR block that's already been pre-filled for you, 10.0.0.0/16, is the one we want to keep, so we'll just leave it there for now. And then we'll keep this selection of no IPv6 CIDR block over here, because this option basically lets you have a different kind of address, or lets you have a different kind of way to define this block of addresses that you want for your city. But IPv6 stuff is slightly more complex, and we don't really need to get to that territory because IPv4, this CIDR block that we've defined here, is plenty for us to work with. Look at that. Just by defining 10.0.0.0/16, we already have 65,536 IP addresses to work with. And yeah, tenancy, we'll keep it at default. And then here in the number of availability zones, we're going to change that option to just one availability zone. We only need one. And then we can also just make sure that the number of public subnets is one, number of private subnets, just one. So we only need one availability zone, only one subnet, and one private subnet. Once you've selected those, you're going to notice that your resource map, look at that, it's already shrunk by quite a bit, hasn't it? So before we had 4 subnets, now we only have 2 because one public subnet, one private subnet. Same with the route tables as well. And then the network connections, we just have an internet gateway, which is perfect. Now, one thing that you can definitely customize, even after you've said, I want one availability zone and I want one subnet that's public, one subnet that's private, you can still go through here and customize it even further. So the first availability zone in your dropdown is perfect. And in terms of number of public, in terms of your public subnet and your private subnet, the CIDR block for those, you can absolutely update that too. So our project step-by-step guide has given you a suggestion on what you can update it to. But as a heads up, this isn't going to make a big impact on your project for today. It's more that defining it in the way that we've always defined it in the first 4 projects makes things really, really consistent for you. So we'll just update the CIDR blocks for your public and your private subnet. And if you're wanting an explanation on what subnets are, what's the difference between public and private subnets, what does it mean to define a CIDR block for a subnet, all of that has been explained before in the first 4 projects, so you can absolutely check those out, check the links for those out as well. And the links to all of those are in the description box. And yeah, make sure when you get here, we're going to make sure we are not selecting any NAT gateways. We don't need any of those. And we also will choose none for VPC endpoints. So NAT gateways is something that will allow your private subnet to get access to the internet. And then VPC endpoints is a way for our VPC to connect directly with an AWS resource, an AWS service like an S3 service or S3 bucket. We don't need that for our VPC today, so we'll be choosing none. And more importantly, NAT gateways actually cost money, so make sure you choose none here so that you don't get charged at all for this project. really tricky that they default it to in one availability zone, which means by default you will be deploying a NAT gateway, which will cost you money. So make sure we're clicking none here, guys. Okay, so once we've clicked none, we'll leave all of these options ticked, and then we'll go straight to creating the VPC. So that's awesome. Let's create the VPC. Cool. Oh, it says I'm signed out of the account. Please reload to sign in. Okay. Oops, this is not part of the project. So here's a little intermission while I sign into the account again. That's funny. Let's try signing in one more time. Okay, okie dokie. I'm gonna sign in one more time. And in the meantime, a big hello to Uliana, who's just joined the live today and says, hello, everyone. Hi, Uliana. So good to see you. And we also have Akshar asking a question. Is it also safe if I'm using my company account? Yes, it is absolutely safe. As a heads up, please make sure you're using an IAM user when you're doing this project instead of using your company account's root user to complete the project. And that's just for security reasons, and also to make sure there's a bit of separation between what you're doing for the company account and what you're doing, personally. It is really easy to set up an IAM user. So if you're curious how to do that, we have a quick link on how to do that in the description box. But absolutely, you're free to ask questions as well if you've never created one before. Cool. So I was in the middle of creating a VPC when it asked me to sign in again. So goodness me. But let's just get back on track by typing in NextWork under name tag auto generation. We have our CIDR block. So I'll just make sure we're all seeing the same thing. So we have our CIDR blocks to 10.0.0.0/16 is what we want. That's perfectly fine. IPv6, we don't need that. Tenancy, we'll keep it at default. And then for the number of availability zones, we only need one, which means we only need one public subnet and one private subnet. And yes, no NAT gateways, please, and no VPC endpoints, please. Let's create the VPC for reals this time. And the moment you click create, look at how quickly this service will create all of these resources for you. Wow, when we had to do it manually, it definitely took a bit more time than this, that's for sure. But all of the resources we've defined have just been created. You can even scroll down and see this resource map that confirms that all of these resources have just been sorted out for you. So that was extremely fast, very impressive. But what we're going to do now is, even though these resources have been created for us, it's always a good idea to make sure that you are across what has been created. So to make sure that we're across it, we're going to do something that's a little bit old-fashioned, and we're going to be renaming these one by one into names that we can easily recognize, because that will help us out a lot for the rest of this project. We're going to be using these resources a lot. You're going to want to make sure it's easy for you to identify what is what. So we're going to rename it and make it a bit more readable and make it a bit more user-friendly. But yeah, I love this resource map because you can actually click on any one of these resources and also see the connections that it has with other resources that you've just created. So if I were to click on, this public subnet, it tells me straight away, this is the CIDR block for my public subnet. It is connected to a public route table. And then there's also a internet gateway that is connected to as well. So that's pretty handy. Awesome, we have Dinesh giving a smiley face. Hi, Dinesh. Awesome. So once you have set everything up, it's time for renaming the resources. So let's tidy up all of their names, and we'll just take 3 minutes to rename, for example, the VPC, the subnets, the route tables, and the internet gateway. Let's do it now. So first things first, let's rename the VPC. Should be easy as. All we gotta do is click on your VPCs on the left-hand bar, and then we'll just click on this we'll hover over the name, NextWork VPC, like this. NextWork VPC like this, and click on that pencil icon. Once you click on the pencil icon, this little panel says, lets you edit the name, and we'll type in NextWork VPC here. Done. So we'll click save. Boom. All done. That was really easy. I think that was pretty smooth. You could rename your VPC just in a second like that. And let's move on and do the same for our subnets. So our subnets are looking pretty cute. I love that once we did name tag auto generation, it's so easy to identify that, oh yeah, this is my NextWork subnet. Like this is a subnet I just created in the VPC wizard. And then you can click again on the pencil icon, and let's rename our public subnet into something that's very easy to read. So we're going to call it the NextWork public subnet like this. Save that. And then same with our private subnet. Let's click on this and call it the NextWork private subnet. Save that. Perfect. That was really good. And as a reminder, what are subnets? So VPCs are the city. Subnets are like the neighborhoods within that city. So if you have a huge city and this is where you launch all of your resources, subnets are a really good way to organize your resources into smaller groups, into smaller neighborhoods. A public subnet is where the resources will be accessible to the accessible by the internet, so people from the public internet can access the resources that you launch into the public subnet, whereas the private subnet is like a gated community. So if public subnets are like the shopping malls and the public pools and the parks in the city, the private subnet is like it's like a neighborhood of homes, like private homes, where I don't think a tourist can just waltz into someone's home and be like, hi, I'm here. Although they could probably do that in a public subnet where there's like shopping malls, you know? So think of it in that way. Private subnets are absolutely private resources. Public subnets are for public resources. And B asks, is subnet per resource, say instance? If not, what decides how many of public and private subnet we need? Very good question. So B is asking about how many resources do we launch in a subnet? And how do we know we need a public subnet? How do we know we need to create a new subnet? How do we know how many subnets we need to create for a real life project? So subnets are usually separated based on what project you're working on, because again, you can think of subnets as just folders or like ways to organize your resources. So if you have a big web app that you're creating, possibly everything that's a public resource for that web app goes into one subnet. Everything that's a private resource for that web app goes into its own subnet. And then say you're creating a completely different project. Let's say you're creating like a separate database project that's going on. That will probably have their own subnets. In fact, sometimes people will go as far as to creating multiple VPCs for different projects if they have really complex networking requirements for each. But absolutely, you would just have at least a separate subnet for different projects. And sometimes having a new subnet and having a new resources within that subnet, it also just comes down to what kind of security settings that you want. So eventually you'll learn about, network ACLs, and network ACLs are how you can set up security settings at a network, at a subnet level. So if you have very specific requirements for all resources in like a folder in a subnet, then they should all be in one subnet. But if you're like, oh, hold on, I'm about to add a new resource to my project, but it has completely different security settings. Maybe that requires its own subnet, so you can manage it. So you can easily manage two different kinds of settings at the same time by putting them in two different subnets. So there are a lot of different ways you can organize this. There's no rule of thumb, by the way. So absolutely how one developer organizes their subnets could be different from another developer. It's kind of like how we all have computers, but the way we organize files into different like folders in our desktop is completely different from one another. There's no one single system, and the same goes for subnets as well. So I hope that answers the question, B. Let me know. And we have renamed our subnet, so we're ready to move on to the next bit, which is route tables. So with our route tables, we have a public one and we have a private one. Thank you very much to AWS for setting this up for us. Let's rename the public route table to NextWork public route table. I think that's a pretty nice and straightforward name. By the way, fun fact, in our step-by-step guide, if you see a code block like this, you can click into this inline code block and it automatically copies whatever content is in there. That is the latest update for this week. It's been very, very handy. So we have the public route table renamed now. Done. Now let's do the same for the private route table. Let's click on the pencil icon for our private route table. And let us paste that in. So good. Chef's kiss to this easy way to copy things that's inside a code block. I'm a huge fan. Just like that, rename the route tables. Moving on to internet gateways. We have the NextWork Internet Gateway all set up for us as well. So we just have to copy the name, NextWork IG, IG standing for Internet Gateway, and then we'll paste that in. Save it. Done. So a really great reason why renaming resources is great for a project as well, when these resources have been automatically created for you, is that it just helps you with validating that all of the resources that you're expecting for this automation to create has been created. So I know the thing that we're doing right now is like just renaming resources, but this actually goes a really long way in terms of us like literally looking at the resource that's been created for us and validating that it looks okay. Very cool. And Shrida asks, can we create more than 2 subnets for one VPC? Absolutely, you can. So as you can see in our VPC that we've set up, you can see in the resource map that we have one VPC and 2 subnets connected to that VPC. So you can definitely create multiple subnets for one VPC, just like how you can create multiple neighborhoods in one city. Fun fact, you can have up to 200 subnets in a single VPC. 200 is the absolute maximum number of subnets you could have. But before that, you can create as many subnets as you want, as long as it's under 200. Cool. Juliana says, looks really handy, I like it. Vintage Motors, great name, says, hi, Natasha. And Daria says, just like that, boom. We're probably going to say that a lot, I feel. And NextWork ACLs is next. Cool. Now you're going to see that we already have network ACLs created for us by default. But look at this. So when you click on the network ACL that's been automatically associated with 2 subnets, you can also click on this, the 2 subnets line, to notice that it is connected to the public subnet and the private subnet we've just created. So this is absolutely the subnet that's been automatically generated for us. Have a look at the inbound rules and look at what you see. This currently just allows in all traffic, great. It also allows in the outbound rules, it allows out all types of traffic, great. This is exactly the kind of setting that we would create for our public network ACL. But is it the kind of setting we'd set up for our private network ACL? You might remember that when we did project 3 in the series, which is about creating private resources, we needed to set up its own dedicated network ACL so that it's not letting in all kinds of traffic. This is not what we want for our private network, for our private subnet. So let's create a new network ACL to accommodate for the fact that our private subnet needs to have completely all kinds of traffic just cut off from it in terms of inbound traffic and in terms of outbound traffic for now as well. Yeah, Vintage Motor says, I have a question, how will we route traffic between subnets? So traffic between subnets is something that often is created for us, already sorted for us in a route table. So you will learn more about this in project 2 of this series as well. I'd recommend checking it out. But every time you see a route table and you click on it and you see under routes that there is a local target, that means traffic between subnets in the same VPC is already sorted out for you. So yeah, that is how traffic between subnets is already routed. If you were to look at the route table for your subnet, if you were to click into the routes tab and you look at what routes are inside, you will see that there's usually one that's already automatically set up that has a local target, and that means traffic from your subnet can already visit other subnets and vice versa as well. Check out project 2 in this series if you want a more in-depth explanation. Great question, Vintage Motors. But for now, we're going to focus on setting up that network ACL. So let's not forget to do that. Let's create a new network ACL and let's call it NextWork Private Network ACL, just like that. And then the VPC will be the NextWork VPC 2. So let us create this now. Let's set it up. Cool. And once it's set up, you can now associate it with your subnet. So we're going to click on that checkbox next to private NACL, and we're going to click on subnet associations and click on edit subnet associations over here to associate our subnet with the network ACL that we've set up. So we are wanting to associate the private subnet, so let's click on the checkbox for that and then save changes. Nice question from Henry that asks, I guess a network ACL was created automatically as well to protect our subnet. Are we supposed to rename it? Such a good question. You're very onto it. Because yes, we are going to renaming the network ACL that's been created for us as well. So as you can see, we have just created a private network ACL. We have just associated it with our private subnet, and now that means our public subnet is on its own and associated with another network ACL. By the way, if anyone can remember what network ACLs do, add that to the chat. I'd love to see how we've been learning this concept and whether this is something that we're all very, very comfortable with. If you don't know what network ACLs do, don't worry, you can add that to the chat too. In the meantime, let us rename that default network ACL that's been set up for us. Click on that pencil icon for the one that's associated with your public subnet. Click on the pencil icon here and let us edit the name. So let us put in NextWork public NACL here. Edited. Done. Boom. Click save. Very cool. So now we have our public network ACL and the private one all set up. Very, very good. So once that's all set up, you'll notice that your private NACL, if you were to look at the inbound rules, currently it denies all traffic. Not a single piece of traffic can enter your network ACL for now. Same with outbound rules. Click on outbound rules, scroll down, and you'll see that by default, all traffic is denied by default, which is madness. It means all kinds of traffic can't even enter your neighborhood, and all kinds of traffic can't leave the neighborhood. Your network ACL you can think of it as a traffic controller that works at the subnet level. So it protects your subnet, it protects your neighborhood. It controls what kind of traffic can come in or leave the neighborhood. And for now, for our private subnet, our private gated community, we're saying no kind of traffic can enter, no kind of traffic can leave. Ooh, a little bit scary. Well, we'll eventually be letting in some traffic. We just need to know exactly what kind of traffic we want to be letting in before we set up any inbound rules, because this is a really good security principle to follow, the principle of least privilege. Don't give away permissions or don't give away access before you know who you're giving it to or what you're giving away. And also, when you're about to give away access, make sure you're just giving away the minimum level of access they need. Don't give away what they need and more. Just give them exactly the level of access they need, so that you're always in control of who has access to what. So awesome. We have just renamed our network ACL, and we've also just created a new one. Let's move on to the security groups. Last bit of work now. So security groups here, we can create new ones, and we can also observe the ones that have been created automatically for us. So in here, in the security groups, notice how that there are two security groups with a name that's called Launch Wizard 2 and Launch Wizard 1. Very interesting, isn't it? So Launch Wizard 1 was created on the 16th of July. Oh, let's refresh that. Okay, very, very cool. So I don't think this has been updated properly. Let us double check. So if you want to understand which VPC a security group is associated with, you can always just click on the VPC ID and get taken straight to that VPC. Aha! So there's a VPC that's associated with the security group that's in my account right now. But it's not exactly the security group that we want to be working with. It's not exactly the VPC you want to be working with. My VPC, let's have a look at what the ID is. So if you click on your VPCs, if you look at NextWork VPC, you will see that my ID, or the ID for the VPC we just set up, ends in 131. So let us go back to the security groups tab, security groups page, and let's look at which ones are associated with 131. There's just one security group that's associated with the VPC that ends in 131, and that is this cute little security group that's very quiet. You can't even tell, and it's just called default. So this is the reason why sometimes renaming things is so helpful, because what the heck? How can you just tell this is this is the right security group just based on its name? It's just so it can be a little broad or vague sometimes, and that's why renaming things to our own naming conventions can be very helpful. In the meantime, though, let's check out what kind of rules this default security group allows. Click on inbound rules here, and you will notice that currently our security group lets in all kinds of traffic, every single kind of traffic from all different sources. So this is a very generous security group that's basically saying, oh, your traffic, come in. Your traffic, just come in. It has no filtering pretty much. Any kind of traffic can come in. And this isn't exactly the kind of setting that we want for our security group. Again, it is very generous. It's very broad. We want to be a bit more specific. So let us just create a new security group and use that security group instead. So we're going to abandon this default one that's been created for us, and let's create our own one so that we're, again, in control of the security settings of our own network. So our security group name, we'll make that the public security group. So we'll call that NextWork Public Security Group. And then for the description, let us use the description that's provided in the step-by-step guide. So a description is always very simple and straightforward. Right now, we're just going to create a new security group, and the security group is for our public server. So let's name it like that. And for the VPC, make sure you're selecting the NextWork VPC. We don't want to associate a new security group with the default VPC for our account. We don't really need that. It is for the city that we've just built called NextWork VPC. So make sure you're clicking on this one. And then under the inbound rules, we're going to add a new rule, and we're going to make it HTTP. And under source, it should be anywhere IPv4. If you're curious what are security groups, how do these rules work, what are we really creating, we cover all of that in Project 2 of this series, so I absolutely recommend checking Project 2. The link to that is in the description too. At the bottom now that we've set it up, let's click on Create Security Group. So we've created our security group now, and woo! Well done on setting up your VPC. It's now time to see your VPC in action. So we're going to step into the next era of this project by launching resources into our VPC. So you can think of it this way. So far, what we've set up is we've created our own city in this huge country. We've set up the exact block of addresses that will go into our public subnet, so our public neighborhood. We set up a block of addresses to our private neighborhood. It's kind of like we've defined streets for all of these different neighborhoods. We have set up, we have a route table now. A route table is like a GPS, so it helps with any kind of resource or traffic to find their way around our big city. And then we have internet gateways. So internet gateways is, again, how your VPC can have connection to the wider internet. So you can think of the internet gateway almost like a plane or a ship that's about to leave the city, because it can take traffic or data within your city to the internet, and it can also welcome people from the internet to the resources in your city as well. We've also set up network ACLs and security groups, which are kind of like security measures that help control the traffic that can go into a specific neighborhood, that can go into a specific resource. So we set up all of these different components of a city, but our city is actually just barren right now. It's kind of like we set up all of the infrastructure. We've set up how it's going to work, how the security is going to work, how people can find their way around it with the GPS, but there's actually no one inside right now. There's no one inside, and there's also not a single building that's actually been built. So let us actually fill our VPC with a few things in this next stage of the project. So let us launch an EC2 instance in the public subnet, and then later we're going to launch one in the private subnet too. So what we're doing now is kind of like we've set up the land for our city. Now we're going to finally get to building buildings, building houses in that city. Super exciting stuff. Let us visit EC2 in our AWS Management Console. Click on EC2 here, and then we're going to select instances from the left-hand navigation panel and launch a new instance. So this new instance we're going to launch is going to be called NextWork Public Server. And then over here under machine image and under the instance type, let's make sure we're clicking on the free tier eligible ones. So we're going to keep the default selections. Usually the defaults are free tier eligible. Just double check that there's the text free tier eligible in whatever is selected for you. So we're going to choose, Amazon Linux 2023 AMI for the machine image, T2.micro, an iconic choice for the instance type. And then for key pair or key pair login, we're going to select the key pair that we've set up in the previous project. So we're going to select NextWork key pair. If you're like, oh wait, I didn't do the previous project, I haven't created NextWork key pair, don't worry. It's very, very easy to create one. All you have to do is select create new key pair here. Give it the name NextWork key pair. Keep these default settings. You don't even need to change a single thing, and then click create key pair, and you'll be all caught up. That's it. That's all you need to do. Type in NextWork key pair here. Type in NextWork key pair here. Click create key pair. All done. For us, we're just gonna click on the search bar and select NextWork key pair here. Cool, all done. By the way, if you're thinking, oh, I'm kind of new to EC2 instances, I want to do this in a slower pace, you can absolutely find a slower guide for everything we're doing right now in this EC2 instance setup in project 4 of this series. Link to that again is in the description. Cool. So now that we're in the networks settings panel, we're going to click on edit on the top right hand corner of that panel. And then we're going to make sure that the EC2 instance we're setting up right now is being launched in your city in NextWork VPC. And we're going to make sure that this server that we've created is the public server. So it should be in the public subnet. So make sure this here is choosing the NextWork public subnet. Make sure it's not choosing your private subnet. Should we auto assign public IP? Absolutely we should. So let's change disable to enable. Auto assign public IP is something we talked about from the very first project in this series. And as a reminder, what this enabling it does is it makes sure that every single EC2 instance you put into this, you launch into the subnet is going to automatically have a public IP address. And having that public IP address is so important for your server, for your EC2 instance, to actually be reachable by the internet. So absolutely we want to enable that, and we're going to move on to the next bit. I just realized we've done a lot of this without me scrolling, so apologies for that. I'm scrolling to the right area now. And then for firewall or security groups, we've already created the public security group. So let's select an existing security group, and let's choose the right one. We're going to choose NextWork Public Security Group. Cool. When that's all done, you can launch your instance. So click on Launch Instance and watch it get ready. Cool. So our EC2 instance has just been launched now. That was very successful. And in the meantime, we also have Henry replying to Vintage Motors saying, Internet gateways allow your public subnet to be accessible over the internet. A NAT gateway allows your private subnet to have access to the internet. That's completely right, Henry. Nice work. Vintage Motors also says NAT gateway is an embedded network inside a VPC. Very nice analogy. Zda says this is another CS company, correct? CS? Is CS like computer science? I must be missing some context. I wonder what CS stands for. Zda, let us know in the chat. Emmanuel waves. Hi, Emmanuel. So good to see you. This is very cool. So awesome work that we have launched our public server right now. And let's move on and launch the second server for our network. By the way, am I going too fast? Am I going too slow? Let us know in the chat. This is super important for us to keep making even better live project demos as well. So would love to hear your thoughts. So here, when you've launched your EC2 instance, select the Instances tab in your EC2 console. And you can also just select that checkbox next to, oh, let me refresh so it's the right one. There you go. You will see that there's 2 that's terminated. We can ignore that. It should be the ones that's just running. Okay, there we go. This is what the instances page should look like for you as well. And then click on the checkbox next to NextWork public server here. And then we can look at the networking settings to review and validate what we've done. So our public server that we've just launched, this EC2 instance, it has a private IP address. And look at that, the private IP address is within the CIDR block that we've defined for our public resources, so that's cool to see. There's also a public IPv4 address, so remember how we just ticked enable auto assign public IP address? Because we've ticked that, we are this public server also gets a public address too, so that's very, very handy. There's a subnet ID, so this validates that whatever EC2 instance we've just created has been successfully launched into our public subnet. And the public subnet has this availability zone. Again, that's completely correct. When we first set up our VPC using the resource map that had that big map with all of the connections between our things, that setup page asked us for the availability zone. We said we just want one availability zone, and this is the one that we've set up. So that's perfect. Your availability zone name might look different. If it looks different, that's totally normal. It just means that our availability zones are in different regions in AWS. You know, I'm working off of the Oregon region. You might be working off of a different region. So your availability zone name will look different. And here we even have the VPC that your server is in. Perfect. That is a NextWork VPC. Exactly what we want to see. So that was awesome. We've just validated that the public server we've launched is in the network that we want it to be in. It's in the city that we want it to be in. It's in the subnet that we want it to be in. So it's in the right neighborhood. We love that, you know, it has a public IP address as well. So everything is cool. Stars are aligned. Let's move on to the next bit. Because the next bit is we're doing a very, very similar step. We're following some very similar steps. But this time we're going to be launching into the private subnet. Thank you so much, Akil, for saying adequate speed. Very glad to hear. And Dinesh also asks, what are some beginner projects one can start learning? Wow, beginner projects? There's so many beginner projects you could be doing. I would highly recommend that you check out the list of projects that we have in NextWork's web app. So you can find the link to that, all of our projects, just in the link in the description. And out of those, there are so many you can pick that's absolutely beginner friendly. I'm sure everyone in the community would highly recommend the one that's under storage, that's called Host a Static Website with Amazon S3. That is like the classic beginner project you could start with. But a lot of these projects are very, very beginner friendly. Just click on all of the projects in the list when you open the website and look for the ones with the difficulty level called easy peasy. Those easy peasy ones, highly recommend as your very first project to do as a beginner. Cool. So now that we've launched the public server, let's launch the private server. So here, let's launch another instance here. And under name, let's give it the name NextWork private server. Perfect. Cool. So it has the name private server. We're going to give it the exact same settings in terms of the Amazon machine image, as well as the instance type. And then the key pair will be NextWork key pair. Just use the exact same key pair. And then we are going to edit our network settings again. So click on edit, and then under VPC, click on NextWork VPC here. This time, do we need to auto assign a public IP? Have a think. Do we need to auto-assign a public IP for resources in the private subnet? Make sure that private subnet is selected. Do you think resources in the private subnet will need a public IP address? Good questions, good questions. So the answer to that is no. We can leave that as disabled because resources in a private subnet should be kept private. We don't want it to be available to the internet. So if we were to auto assign it a public IP, that means it is actually reachable over the internet or there's an address for it in the public internet space. We don't really need that. So let's disable that, keep that disabled. And then for security groups, we don't have a security group set up for our private subnet yet. So what that means is we're going to create something from scratch here, and we're going to call it the NextWork private security group and the security group name. And then the description, something pretty spicy. No, just kidding. It's not that spicy. It's just a very straightforward description that says security group for your NextWork private server. So that's exactly what the security group is set up for. And just like that, you can also set up your inbound security group rules. So you can see here that notice that under the inbound security group rules, there's a rule with a type that's set to SSH. Interesting. What is SSH? So SSH is extremely important in this project, so we're going to talk about this right now. SSH stands for Secure Shell, and it is a protocol that we use to securely access a remote machine. You might be like, whoa, lots of technical terms here. What are you talking about? So a remote machine, in this case, is the EC2 instance that we're launching, and secure access is basically being able to control that machine in a very secure way that's not exposed to the public internet. So when you connect to the instance, when you connect to your EC2 instance, SSH is the protocol that verifies that you have the right private key, because in here we have a key pair all set up, and that key pair is made out of two keys: a private key that you're going to own, and then a public key that goes into the EC2 instance. So this public key and this private key together are a key pair because you have to put these keys together to unlock your EC2 instance. And in this case, SSH is also a protocol that will help you use your private key to visit the EC2 instance you want to connect with and literally make them try to connect to be like, oh, do they match? Are they a match? Can we unlock this EC2 instance with your private key? SSH would be like, oh, it's a match. Yes, you're let in. Or SSH could be like, no, it's not a match. Don't even think about coming into this EC2 instance. Access is barred. So you can think of SSH as a very, very important protocol for us to learn in order to be able to securely connect to an EC2 instance. So you can also notice that it is a traffic type. So our security group is also now set up to let in SSH traffic, which means once you unlock your EC2 instance with that key pair unlocked, SSH becomes a traffic type because SSH is going to now be like, okay, you're now connected. All of the data you're transmitting from yourself, you connecting to the EC2 instance, from yourself all the way to the EC2 instance will be encrypted. So it'll be very, very secure. What you're sending, the data you're sending to your EC2 instance is going to be encrypted. Data going from your EC2 instance to you is also going to be encrypted. And that encryption is handled by SSH. So what that means is SSH also becomes a type of traffic that your security group can let in or let out as well. This is extremely important. SSH is absolutely being used in today's world. And you can think of SSH in this way, in a very, very boiled down format. Do I need to connect directly to my EC2 instance to run some commands inside that EC2 instance's terminal? Do I need to install applications directly into that EC2 instance? Do I need to change any sort of configuration in my EC2 instance's software? Or you can say its operating system, its OS. If the answer is yes, most likely engineers will be using SSH in order to connect to that EC2 instance and then make those changes. So extremely important. I can't emphasize it enough. And yeah, once we have set up an SSH security group rule over here, notice that there's a yellow banner that says, hello, you're using a source type that says anywhere. Anywhere opens it up to the entire world. Any IP address can now access your instance using SSH. Hmm, not really what we want for private server. So let us change that. Oh, let us change that because we want to keep our private server private. So from here, instead of having anywhere as our source type, let's change it to custom because we're going to custom make a specific kind of source that can be let into our private server. And that source is going to be, as you scroll down in this search bar, it's going to be our public security group. So cool. I love that under a source, you can define a security group as a source as well. Because what this is saying is out of all of the IP addresses in the world, the only IP addresses that can connect to my private server using SSH or connect to your private server using SSH is the IP addresses that belong in your public security group or connected to your public security group. Super, super handy because instantly it narrows down the scope from all IP addresses being able to connect to your private server down to just the resources that are connected to your private security group can now SSH or connect to your private server. So secures your server so much by having this setting set up. Very cool. Awesome. Fubara in the chat says, "Hi Nat, I think we can launch more than one instance at the same time, right? Then we can rename them public and private, right?" Yes, it is possible to launch multiple instances at the same time. CloudFormation or infrastructure as code is a great example of being able to launch multiple instances. Personally, I personally am not very familiar with launching multiple at once through the management console, just like using clicks. But if there's a way that you're familiar with, I think it's a fun thing to experiment with. Can we use the management console to launch, multiple servers at once? I'd be interested. Or do you mean like number of instances here and change that to 2 like that? If this is what you're referring to, Fubara, I'm guessing it is. It is definitely possible to launch multiple resources at the same time. It is just that if you were to click on 2 here and click on launch instance straight away, it would have the same security group settings. And ideally, because we have a public server and a private server, we want them to have different security settings, or I should say security group settings. Another thing that's different between our private server and the public server is also the fact that they're in different subnets. They also have different settings for auto-assign public IP. So there are a few different settings that we want to be able to just configure properly from the get-go. And that's why we wouldn't really select 2 instances at once. If I was to create 2 of the exact same settings, and these instances need to be in the exact same subnet, they do the exact same things, I would probably click 2 here. But not in this case, given that we have very, very different network settings set up for our public server and for our private server. So keep that as 1, and we have set up our security group rules, SSH, and let's launch the instance. Barak in the chat says, "Hello, Natasha. Really came in late, but better late than never." Correct. Thank you so much for being here, Barak. That's really cool. And we also have Abdul. I almost missed this message, Abdul. Thank you so much for messaging Dinesh and saying there are some cool projects in the community. Hosting static website on Amazon S3 is cool to start with. Oh my gosh, Jinx, we recommended the exact same project to Dinesh. Dinesh, that means you absolutely need to try that project now. So cool. We have set up our VPC properly. Hooray! We've done that. So now let's go into connecting to the public server. So let's try talking to the public server in this new step here. So how do we connect to the private server, public server? We're going to use a service called EC2 Instance Connect. And how that works is in the EC2 console, we're going to select instances here, and we're going to select on your public server. Once you've selected your public server, click on Connect. All right, so you might be wondering, what is connecting? What does this mean? So connectivity which is exactly the theme of this entire project as well, is all about how well different parts of your network can talk to each other and with the external networks. Connectivity is really important because it is really good to have good connectivity so that data can flow smoothly. Poor connectivity would be like if data that's supposed to reach your EC2 instance can't reach it because of something that you've set up that blocks that traffic from getting to your EC2 instance. That would be like poor connectivity. Netflix, if we're thinking about a larger scale, uses over 100,000 EC2 instances to power its streaming platform, to store all of its streaming content, like all of the TV shows, all of the movies are being stored somewhere. And when you have so many components at such a large scale, 100,000 EC2 instances, solid connectivity becomes so important because you want to be able to manage so many resources in a very, very efficient way. So this honestly brings into perspective the importance of networking. We're using a relatively simpler network today, but the concepts are still the same, even in a much larger scale. So in this step, what connectivity are we testing? We're going to be setting up a public server. We've set it up. Now we're going to test whether we can talk to the public server. This involves fine-tuning a lot of your security settings to make sure that connection can exist. So what's going to be interesting here is we're going to be using something called EC2 Instance Connect, which is a special kind of tool or service within EC2 to connect to our public server today. So EC2 Instance Connect you can think of it as a shortcut way to directly SSH into your EC2 instance. You know how we talked about SSH just now, and we said SSH, Secure Shell, is a very secure way to get direct access to your EC2 instance. It also means that SSH is like trying to match your private key with the EC2 instance's public key to see whether they match and whether we can unlock them. EC2 Instance Connect is a way for us to be able to set up that entire SSH connection in a very, very easy way. Put it this way, if EC2 Instance Connect didn't exist, the steps to connect to our EC2 instance is going to be a little bit more complicated, and it's going to live off of the AWS Management Console, which adds another bit of complexity. But because EC2 Instance Connect, this little shortcut way, exists, we can do all of that connecting to our EC2 instance within the AWS Management Console, within our browser, and also we don't need to manage all of those private key and public keys anymore. Instance Connect does it for us. So it is a very, very great beginner way to learn how to get access to an EC2 instance. And you can see this little diagram as a summary as well. Without EC2 Instance Connect, you yourself have to use something called an SSH client. You need to create and manage your key pairs by yourself in order to get access to the public server. But because we have EC2 Instance Connect, we have this very cool tool. Instance Connect is just going to create and manage those key pairs for us. And then we can also just use the management console, what we have in front of us, to get access to the public server. So it saves us so much time and effort. Highly recommend. I can't believe, fun fact, that the EC2 Instance Connect, this tool was only created last year. So it's a very, very new tool that we're using, and a very, very practical tool. So let us try to select Connect. Let us just try clicking on Connect here and see whether we can connect to our public server right away. Shall we do that? Click Connect in this EC2 Instance Connect page and watch it load. So it's going to try establish a connection now. What's happening right now is you're using EC2 Instance Connect to be like, can you help me talk to, like, just connect to my public server? Can I get access to my public server directly? No. As you can see from the red error message, no, we can't. We can't get access to it right now. Why is that? Let's troubleshoot this, but in the meantime, take a screenshot. Let's take a screenshot of what we see in our screen, which is an error message that says we failed to connect to our EC2 instance. And let's upload that. So I'm going to take a screenshot. I'm going to upload that. Boom. Done. Uploaded. Looks good. Oh. I think that's excellent. And let's answer a few questions. So, what does connectivity mean? Connectivity means getting resources in our network to communicate with each other and how well they can communicate, deliver data to each other. So you can say without connectivity, resources in our network, you can put it this way. I would say resources in our network would not be able to, cannot communicate, e.g. users can't access our applications. I got cut off. I don't have enough characters left. Without connectivity, resources cannot communicate. For example, users cannot access our application. So that's an example of the importance of connectivity. Next, which server were you trying to connect to in this step? Very good question. I wonder, do you know the answer to this one? Have a think. Which server? My first connectivity test was whether I could connect to my network's public server, an EC2 instance. Done. Just like that. You can double check that everything is right. Let's see if we have any typos here. Looks pretty good to me. Any typos here? I think that looks pretty good. And then my screenshot looked great. So I think that's all good. I'm going to click done. And that's that box done. Awesome. Oh, Barack says, I'm enjoying the session all the way from Nairobi, Kenya. That's cool. I'm waving hi from Wellington, New Zealand. Henry asks, are we going to do projects on CloudFormation or Terraform to launch multiple infrastructures? That's going to be mind-blowing. You are the best, Natasha. Thank you, Henry. This is so cool. We have touched on CloudFormation before in our DevOps series. Absolutely, we want to go into Terraform as well, go deeper into Terraform. There's a plan for that. And launching multiple infrastructures, we haven't really gotten to there yet because the LV is just so advanced. And that is well beyond, for example, the cloud practitioner level of hands-on experience. But honestly, I agree. It's going to be mind-blowing. Very worthwhile thinking about. So we'll think about that, Henry. Can use option use launch more like these in the console. Wow, GBK, is that something that you enjoyed, that we use the console to launch the resources? That's awesome. Okay, so we have just answered a few tasks, but the question still remains. Why is it that we failed to connect to our EC2 instance? We've just tried to set up a connection to go from you to your public server, but your public server can't be connected to right now. Why is that? If you ever see an error around failing to connect, reading the error message, of course, is first. EC2 instance connect is unable to connect to your instance. Ensure your instance network settings are configured correctly. For more information, use EC2 instance connect prerequisites at, and there's even a resource for this. You can absolutely visit this link, by the way, and read the prerequisites and see whether or not you can troubleshoot it yourself. But what we're going to do next in this project is going to go directly into troubleshooting that. So let us follow this error message's advice, and in a new tab, let's investigate our EC2 instance. So it's set to investigate the network settings for your EC2 instance. And let's do that. So over here, you can go into VPC to look into your network settings, or you can, since this has already been selected for us, click on the networking tab and look at what your networking settings are. So we know that our public server is connected to a VPC. It is also in a subnet called NextWork public subnet. So if we were to talk about networking settings being slightly off, we can start by looking at what are the networking settings or security settings associated with the VPC we're connected with and associated with the subnet that we're in. So let's click on the subnet, NextWork public subnet. And that takes us into our VPC console and back into the subnet that we've created. And if we were to click on NextWork public subnet, you'll see that there's a route table associated with it and a network ACL. Our route table looks good. Our route table says that our public subnet can effectively route traffic to the internet and also welcome traffic from the internet as well. This internet gateway is a route in our public subnet, which means if there's ever traffic that is coming inbound from the internet, or if there's any traffic that needs to go outbound to the internet from our subnet, it can do that. There's a route for that. So route tables actually check out. This is completely good. What about network ACLs? So let's click on the network ACL tab, and interesting stuff. You'll see that all traffic is allowed over here. Cool. Now, interesting actually, because we're just gonna make sure that this is what we want to see. Is this what we want to see? Have a think. Is it good that our public subnet, the network ACL, is allowing all inbound traffic and allowing all outbound traffic? That was a quick trick question. It is completely okay. This is good. This is what we want to see. Because allowing all traffic in, allowing all traffic out just means that if we want to SSH, securely access our subnet, the network ACL is not going to stop us. I feel a little cheeky because I feel like the way I reacted was a little misleading. I was like, almost like tricking you into thinking that there's a problem with the network ACLs, but there absolutely isn't. This is a great rule that just allows all kinds of traffic in and out, which, at a glance might be like, oh, this is a bit unsafe. But actually, if your server needs to be public and your resource needs to be public to the internet, you're going to want to make sure all different kinds of traffic can actually visit it. But yes, our network ACLs check out. So that's not the problem. What else could be the reason why we can't connect to our public server? Now, don't forget, aside from network ACLs, there's another tool that can control traffic flow. That other tool is the security groups. So select on security groups in the left-hand navigation panel for your VPC dashboard. And let's look at your public security group. Check that and check the inbound rules. Okay, so we're looking at the inbound rules now, and what do you see? Ooh, interesting. So this actually answers our mystery. I'm going to tell you now, there's an issue with the inbound rules, but can you tell what that issue is? Let me scroll and show you. Our inbound rules currently lets in all HTTP traffic, goes to port 80. The source is all IP addresses. So all IP addresses wanting to visit our public server can do so through HTTP traffic. Is that cool? Is that cool? Have a look, have a think, and you can add your response to the chat, or just like think to yourself, like, is this the right inbound rule for us? I wonder what we're thinking. Okay. So the response to that is this inbound rule is not the best inbound rule for our public server right now because it is only letting in HTTP type traffic. Do you remember how we've mentioned before that SSH is its own kind of traffic? It's its own protocol. It is not HTTP traffic. So we need to edit the inbound rules over here, and we need to add a rule to make sure our security group can actually let in SSH traffic as well. So what's happening right now is even though our network ACLs are letting in is letting in SSH traffic. The security group is not. So that's like a bouncer at the door of your public server and saying, sorry, you can't access. I can't let in SSH traffic. And you, using EC2 Instance Connect, is trying to visit your public server with SSH traffic. So it's just being turned away at the door of your public server. A great shout out to Fubara and Andre for correctly identifying that you need to open an inbound rule that lets in SSH traffic. So let's do that right now. So the type here is going to be SSH. Click that. And then for the source, what do you think the source could be? Yeah, for the source type, we can actually just allow anywhere. We can just open it up again. This is a public server. And honestly, having everywhere for a public server is okay compared to, if it was a private server and we need to have very, very strict security rules. So that was very easy. We're now saying any kind of traffic, any kind of SSH traffic is allowed to visit your public server. Congratulations, that's exactly what we want. So let's save the rules now. Very nice. And a shout out to King of Zamunda saying, hello, hello, I know I'm pretty late. Good to see you. Thank you, King of Zamunda. It is so good to see you, King of Zamunda. And thank you so much for being here again. GBK also mentioned IAM role needed to use Instance Connect. Very good suggestion, GBK. Luckily, my IAM user automatically already has access to use EC2 Instance Connect, so it's not the issue for today. But this could absolutely be the situation for another user that can't use EC2 Instance Connect. Absolutely. If someone doesn't have the right IAM users permissions, they wouldn't be able to access it either. So great shout. Great point. So now that we have allowed SSH traffic, let's try connecting to our EC2 instance again. So here we failed to connect. That's okay. Let's try connecting one more time. So I'm going to just close the tab of the existing connection, and I'm going to go back to my EC2 instance in the EC2 console. Again, I'm going to select public server, select connect again. Is it going to work this time? Let's see. It's always nerve-wracking to do it live, isn't it? Woo! But it worked though. Oh my gosh. If you see the success, add a heart to the chat, please. Because that is a very satisfying feeling. We have successfully connected to our public server. When you see the screen and you see that there's a bird, there's Amazon Linux 2023, that is confirmation that you have successfully connected to your EC2 instance. So what does it mean to be successfully connected? What that means is we can now talk directly to our EC2 instance that's hosted somewhere in the cloud. It's so cool. We can now install software, for example. We can now configure our EC2 instance. It is exactly just like having a physical computer in front of you and like working around with it. But this time, we're kind of accessing our EC2 instance in a different way. Instead of having it physically in front of us, we have it virtually in front of us, and we can still control it in the exact same way by using commands in the terminal, which we're about to do. So that was a great success. Congratulations, everyone. We've made it. And let's take a screenshot. I think it's screenshot time. So let's take a screenshot of the successful EC2 instance connection. And let us add that screenshot over here to our step-by-step guide and the screenshot panel. Once it's done, let's answer a few questions. What is EC2 Instance Connect? Let's start there. I connected to my EC2 instance using EC2 Instance Connect, which is a tool provided by Amazon EC2 that allows us to directly access an EC2 instance using the AWS Management Console. We no longer need to manage key pairs. We no longer need to manage key pairs or use an SSH client. Can't type today, clearly. To get access. Again, I am blocked out by the number of characters left. We no longer need to manage key pairs or use an SSH client to connect. Let me make my answers more concise, which is a tool. I would just delete this part, I guess, which is a tool that allows us to directly access an EC2 instance using the AWS Management Console. We no longer need to manage key pairs or use an SSH client to connect. I'm going to be greedy and just finish our sentence to connect our EC2 instance. Full stop. Okay, still one character left, so I'm really happy with this answer. Next question. Why did your first connection attempt fail? Oh my gosh, it did, didn't it? Our first attempt at getting direct access to the public server resulted in an error because, how would you answer this question? It was because, why did it fail? Why did it fail? You can chuck your answer into the chat as well while I type an example one out too. My first attempt at getting direct access to my public server resulted in an error because my private server had a security group that did not allow SSH traffic. It only allowed HTTP traffic, i.e. a different protocol. That was exactly why. And next, how did you fix that error? So I fixed this error by, we did a great job fixing this error. We did this by adding a new inbound rule in my private server's security group that allows SSH traffic from anywhere. Perfect. Awesome. So once you've added your responses, it all looks great. Click done. As a heads up, once you click done, you won't be able to change the screenshots. For now, as of today, you won't be able to change the screenshots, and you also won't be able to edit the text that you've inputted. So it's always a great idea to just double check your responses, make sure there are no typos, make sure you've uploaded the screenshot you want before you click done. Although the ability to edit these boxes and your screenshot is absolutely coming. When it does come, it's going to be a great day. So we've just successfully accessed our public server. Awesome. Next milestone, let us test the connectivity between your EC2 instances. So can you use your public server, which you now have access to talk to your private server? So that is the question we're going to answer in this step. So we're also going to troubleshoot another connection issue in the meantime. So you're going to be very, very familiar with troubleshooting. Detective mode stays on. So what does it mean to actually connect to a private server from the public server? Why will we want a public server to speak to a private server? So when our servers talk or when they connect, that usually means the public server is sending or is requesting data from the private server. This setup is extremely common in real-world architectures because you would have the private server being the server that's hosting your web app, for example, and there'll be users wanting to visit your website, so their traffic visits your public server to retrieve HTML data to load your website on their browser. But let's say you have a web app where users can create an account everyone's account details, like their email and their password, we're going to want to make sure those details are kept private and confidential. So we will have a private server that runs our database that collects all of these profile data, all of these user account data. And now, when a user visits your web app in your public server, it's going to send some confidential data to your public server. It's going to be like, here's my name, here's my email, here's the password I want to set up for my account. Your public server is going to get that data, and it's going to want to send that data to the private server to keep. So that's exactly why connections are important, because if you don't have your resources talking to each other, what's going to happen to the user account's details? It's either going to stay in the public server where it's going to be very vulnerable to attacks, or en route to your private server, if there was something wrong with the connection, that person's user's details are just going to maybe disappear and just fall off the face of the earth. So there's going to be, a few things that could go wrong, if networks aren't set up properly. And that's why connectivity tests, which is what we're doing right now, are so important. So yeah, that is a quick intro into why we're doing this step, and let's get straight into it. So we're going to leave open this tab of your EC2 Instance Connect, but we're going to head back to the EC2 console in a new tab, and we're going to select your private server. Goodness me, look at this typo. That looks not very good. We will edit these typos once this live finishes, I promise. Let's click on and select your private server. And then, looking at your private server's details, you can see that your private server doesn't have a public IPv4 address like we mentioned before. We wanted to make sure that's kept completely private, so it doesn't have a public address that makes it accessible to the internet. Instead, there's a private address, and this address, another fun fact, this sits within your private subnet's VPC CIDR block. So it has its own private address. We're going to copy that. Click copy. We're going to head back to your public server in your EC2 Instance Connect tab, and let's run this command called ping. You type ping into your EC2 Instance Connect terminal. You type ping, you paste the IP address that you've just copied. So now that you have this command ready, click enter on your keyboard. Let's press enter, and there's a response. So if you're wondering, what is ping? I've never used ping before. I am new to this. Let us talk about ping for a quick second. Ping is a tool that you would use to test connectivity between your servers. What ping does is when you type ping and there's an IP address, what you're really doing, I'm going to zoom in so you can see this a bit better. What you're really doing is you are sending a data packet, a piece of data or a piece of traffic from your public server to the private address that you've just defined here. So I'm saying ping, send a piece of data to this IP address that I've mentioned here. And this IP address is what we've copied here. It is the IP address of your private server. So we're trying to send a piece of data to our private server right now. There's no better way to test connectivity than actually trying to just send a piece of data over and see whether it lands. If it lands, if it was a successful connection, ping would have given us a lot of replies back. There will be line after line after line after line that pretty much confirms that your private server has received that packet of data you've sent, and it's also sending a reply back to you to confirm that, like, hi, yes, I've received your data packet, we are connected. But do you see what response is in our terminal right now? Look at this. We only have one response, one line, and this one line just says ping, IP address, and 54 bytes of data. This one line that we see right now in our terminal is basically just saying, I have successfully sent out a piece of data to the IP address you've defined. So our public server that we're connected to is kind of like texting us and saying like, hey friend, just letting you know, I've sent a piece of data 56 bytes of it to the IP address you've just asked me to send it to. So this is the update from your public server, but there are no replies. We know there are no replies because there are no line after line after line after line of feedback. If ping was successful, we'd be seeing that happening right now, and you'll see that in a minute. But for now, we're not seeing this. So what's going on here? Why is it that we are not getting any replies? So we're going to first take a screenshot of this response. So take a screenshot over here, and let's add that to our step-by-step guide. Paste that in, and we're going to click done. Nice, all done. So the reason why we only get, we're not even getting a single reply, so we're getting no replies. The reason why we're not getting any replies, and you can see this diagram pretty much illustrating that relationship happening right now. It's like saying, hello, are you there? Hello? It's not getting a reply back. The reason why is because our private server, or the security settings that it has around it, is blocking your ping messages from reaching your private server. Typically, there's actually two possible reasons for it. You know, there was an issue with your message reaching the private server, or there was an issue with your private server's reply getting back to your public server. So there's two possible reasons why you're not getting any replies back. Maybe the journey to your private server was disrupted, or the journey of your reply back to you, your public server, has been disrupted. In our case, it is actually the first journey. That first leg of that message even reaching your private server has been disrupted. And the reason for that is because your network might be blocking the type of messages used in ping, which is known as ICMP traffic. It is just like what we've run into in the last step, where we're just like, oh, SSH traffic isn't allowed. In this case, it's a different kind of traffic we're talking about here. It's not SSH anymore, it's ICMP. So ICMP, or Internet Control Message Protocol, is a different kind of traffic. And this is the kind of traffic that ping uses. Blocking ICMP traffic is often done by default because network attacks, like attackers wanting to overwhelm a website to the point where it shuts down, often happens using ICMP traffic. But in our case, we're going to want ICMP traffic to be allowed for our private server. So we want our private server to accept ICMP traffic because that is the kind of traffic that we're sending to it using ping. So fair enough, you know that ICMP traffic is often blocked by default, but we're going to change that setting right now in the next step. So to resolve this connectivity error, let's investigate, whether your private server is allowing in ICMP traffic. I know I kind of spoiled it and just told you that no, it isn't. But this next question absolutely still applies to you. Pause and have a think right now. Where do you think you can investigate this? Where do you think you can change the way that your private server is letting in ICMP traffic? How can you change that setting? Have a think, which part of the VPC will you need to change? In the meantime, I love that Joe in the chat says, all I know is the higher my ping, the worse I do in Valorant. Oh my gosh, Joe. I didn't know you play Valorant. That's awesome. Andre says, I guess the text should state illegitimate traffic. Ooh, the text for which part, Andre? Andre also comments security groups. Andre's bet is on the fact that we need to investigate the security groups for our private server to enable ICMP traffic. Very cool. So, let us resume and let us visit our VPC settings, our network settings in a new tab. And let's head to VPC over here. Jerome's bet is also on security groups. So we have 2 bets now on security groups. Any other bets on security groups? I'd love to hear. So let us head to our network settings now. And let us select our subnet. So we have our NextWork private subnet. Let's click on that. And let's click on the route table. Okay, the route table is correctly routing all internal traffic. So any traffic that is just heading to another VPC should have a route to get there. In our case, the public subnet is within the VPC, so it is within this. It is within the scope. Our route table has no issues here. What about the network ACLs? Network ACLs currently deny all inbound traffic. It also denies all outbound traffic. Ooh, looks like our network ACLs might be a culprit in this right now. So, again, our inbound rules for a private subnet network ACL is so important because this network ACL is kind of like a community watchman. It protects, controls security at an entire subnet level. So in this case, we're basically saying that the entire neighborhood that your private server is living in or your private server is being built in, the entire neighborhood is not allowing any kind of traffic from anyone right now. Not a single piece of traffic can be let into the entire neighborhood, let alone to your specific server. So network ACLs absolutely need to change here so that we can allow ICMP traffic. Andre says, with ping messages so it can't respond to legitimate traffic. Oh, yes. Very, very good. Very, very good point. We shall update actually our step-by-step guide so that we can do that. I am writing a message to myself right now to say illegitimate traffic so that we can update our step-by-step guide. It's a very, very good term to use too. And yeah, Akil says, there it is. All traffic inbound is denied. It's not receiving anything. You're following on very, very well, Akil. That's completely right. Mystery solved. So now that we know that the network ACLs is a culprit, let us edit it and fix it up. So click on the link that takes you straight to your private network ACL, select it, and you can now change the inbound rules. So we're going to edit the inbound rules here, and we're going to add a new rule. We're going to name it 100. If you're new to network ACLs, you don't really know how inbound rules work, check out Project 2 in this series, by the way. And then the type, like we mentioned before, is ICMP traffic. So we're going to select ICMP, and out of all of these options, let's just select, I think all ICMP is the perfect one. So we have selected all ICMP now, and notice that we can set the source for something, and let's just set the source to something that is coming from your public subnet. Cool. So our source, again, is like, okay, I'm going to let in ICMP traffic, but ICMP traffic from where? Where in this entire world of IP addresses can send the private server ICMP traffic? And we're saying, yeah, all traffic coming from my own public subnet, which has this CIDR block, can send ICMP traffic. So we're still going to block ICMP traffic from the public internet and other people, but in terms of your public subnet, that subnet or resources in that subnet can now send ICMP traffic. So that's great news. And we're going to allow that. Awesome. Save your changes. Done. That was very good. Let's do the same for your outbound rules. So let's edit your outbound rules, and let's add a new rule that allows out all ICMP traffic to your public subnet. So save that. Done. That was very, very cool. GVK says private server should allow traffic from the web server security group. Very, very good question. And we're going to talk about why we haven't done that in just a second. Very, very good point, though. So what GVK is mentioning over here right now is whether or not we should make our private servers network ACL even stricter, so that the source and the range in that source field that we entered is even more smaller, is even more specific. That would be very, very good practice, and we're going to show you just in a second why we haven't done that. So, cool. Next, we're going to go into our security groups. So we're going to click on security group, and then we're also going to investigate what are the inbound rules for the security group. Click on that and click on inbound rules here. What's going on here? Aha! SSH traffic is now allowed for your security group, as you can see. But is ICMP traffic allowed? No, it's not. It's not allowed. So we're going to need to allow ICMP traffic too. So we're going to edit the inbound rules. Again, let's add a new rule. The type is ICMP. And then for the source, we're going to make sure it's custom as well. Always remember that security groups should be as strict as possible, and let us select a very specific source here. So we're going to select the NextWork public security group. Very cool. Let's save. All done. So now we're also saying that for our security group, so again, the security group is like the bouncer that stands in front of a building's door. And we're basically saying this bouncer can now let in ICMP traffic as well. Before, your bouncer would turn away all ICMP traffic, and that would not be good for your ping message, because your ping message can do such a great job traveling, across the public subnet, leave the public subnet, even enter the private subnet. But then the moment it gets to your private server, your security group's like, nope, can't be let in, sorry, you're gonna have to go back. I love that Clark comments, long live ICMP. Long live ICMP indeed. So, like I mentioned before, that's the reason why we need to make sure our private security group settings are set up properly too. Not just the network ACL, also the security group. So you have your public security group, you have your ping message. You can think of your ping messages journey in blue. So it goes through to the public network ACL. It goes into the private network ACL. We've just set it up to allow ICMP traffic, so it gets let in to your private subnet. Perfect. But the moment it gets to the door of your private server, it gets blocked if you hadn't enabled those inbound rules as well. So that's the reason why we definitely needed to enable those inbound rules too. And now that we've done it, congratulations, you have configured your private security group to let in ICMP traffic as well. Cool. So now we get to talk about the question that GVK mentioned in the chat as well. GVK previously mentioned, your private server should only allow traffic from web server security group, and we've done that. So GVK, we've answered your question. We have in the security group level only allowed in traffic that's coming from the web server or coming from the public security group. And the reason why our NACLs or the network ACLs didn't have that is because network ACLs typically do have a much broader scope, because its settings would affect all of the resources within that subnet. Again, network ACLs are at the subnet level. It affects the entire neighborhood. So whatever restrictions you put on your network ACL, those are restrictions that you put for the entire neighborhood. So sometimes you're going to want the network ACLs to be a little bit broader in terms of what it allows in, compared to the security group, which is like the bouncer that's at the door and is at the instance level. So we can even illustrate this with an example scenario. What would happen if your VPC was so big that it didn't have just one private server, it didn't have just one public server, it had two of each? If that was the case, you would want your network ACL, the traffic controller at the subnet level, to let in both kinds of traffic that is coming from both public servers. Let's look at this diagram here. Imagine if our VPC setup was a bit more complicated and there are more components in here. You're going to want both your public security group or traffic from both public servers to be able to reach their corresponding private servers. If your private network ACL only let in traffic from a specific security group, then the traffic that's coming from the other security group won't be let in. It'll just be blocked at the neighborhood level, at the subnet level, and it can never reach the server that it's trying to reach. So that's why just now when we set up your private network ACL, the source of that was the IP CIDR range for your entire subnet. Whereas for the security group, you can see here for your security group, the source is a bit more specific. It is the public security group, whereas for a network ACL, it was letting in traffic from the entire subnet, this blue box here. And that's why, again, we love having both network ACLs and security groups. They work in different scopes, and they also make sure that enough traffic is being let in, but also not so much traffic that all kinds of traffic can be let into your neighborhood, into your subnet. So Clark, I hope that answers your question as well about whether we're diving into NACLs in this session. We are, and we actually just passed fixing up the network ACLs. So that's why we are into the security groups part now. Okay, phew, that was a big detour. That was a big explanation on security groups and network ACLs. Great job on editing the configuration for those. So let us save those rules and let's revisit our EC2 Instance Connect tab. Oh, did we save those rules properly? Before I forget. Oh. All ICMP traffic coming from the NextWork public security group is set up. Yep, we click on Save Rules. Oh, okay, cool. That looks good. So our private security group has the right inbound rules. All ICMP traffic from the security group is let in now. And then let's also double check that the network ACL is correct. So our private NACLs, is it letting in inbound traffic? Perfect. Is it allowing outbound traffic? Perfect. So that's great. That looks really, really good. And the protocol here says ICMP1. So I'm just going to double check if that is the right protocol. Yep, that should be good. And then we're going to look at the EC2 Instance Connect tab. Now, what was actually supposed to happen here is we were supposed to see a lot of traffic coming through because technically our traffic security settings should be all set up to allow ping traffic now. But actually what we're seeing here is something that we're not expecting for this project. Ping traffic isn't coming through. So I wonder why. If you have your own suggestions, would love to hear it. In the meantime, I think what could be happening is maybe the network ACL rules weren't set up properly, perhaps, or maybe the security group rules weren't set up properly, perhaps as well. I have my own suspicions on what was the error we've just run into, and I'd love to hear your suggestions too. Cool. I'm going to start by checking our security group settings again, and then checking, is this the right security group for the right VPC? Yes, it is. The VPC ends in 131, so that's the correct VPC. Is this the correct security group that's currently associated with my private server? Let's see. Let's check our private server and see whether it's associated with the right security group. So we can even go into private server, we can go into security, and we can check. Yep, it is connected with the right private security group. That's correct. What about our public server? Is it connected with the right security group? Let's check. Yep, it's connected with the right public security group too. So, what could be the reason why we run into this error? Let's keep investigating. If you have any suggestions, let us add that to the chat. Interesting. Okay, so Akil says, shouldn't we just try sending the data pack again? Good question. And we can do that. So let us go into our EC2 Instance Connect tab. Let us again find our private server's private IP address, and let's try ping that again. Again, we're still only seeing one message, which is just saying that we've sent the ping message across. Doesn't quite have any packets come back to us. So what's going on? This is cool. We're troubleshooting, like we're doing some real troubleshooting about the project live right now. I would love to figure out what's going on here. Let's see. We have our security group. Does it have... It's allowing out all traffic, our security group, our private security group, so that's correct. Inbound rules. All ICMP traffic should be allowed out, so that should be correct too. Yeah, Akil says doesn't seem right. Let's check our inbound rules one more time. Let us try configure something by just saying allow all inbound traffic. Oh, okay. Cancel this. Let us try something different just to troubleshoot this. And let's say, what if instead of saying the source was just our security group, what if we said the source could be all kinds of traffic? Let's see that. Let's see if something could happen here. Oh, can we do that? You may not specify an IPv4 CIDR for an existing reference group ID rule. Ooh. Oh, okay, I see. You just have to delete this, add a new rule, and then let's see if we can let in all ICMP traffic coming from literally anywhere. This is just to troubleshoot and see if this would actually let in this will actually create ping messages. Doesn't yet. I'm wondering if that means that there's an issue before the security group, because the security group is just the layer outside of surrounding your EC2 instance, surrounding your private server. Could this be an issue with the network ACL? Let's check. Let's check the network ACL and see what kind of inbound traffic it's allowing in. And let's edit this and again make it allow literally all kinds of traffic. So I'm gonna go 0.0.0.0/0, and let's save this so it allows all kinds of ICMP traffic. So now our private network ACL, at the subnet level, at the neighborhood level, is also going to allow in all kinds of ICMP traffic. Is that going to change anything? Still no. Since there's no ping T, you might need to relaunch it. Should we do that? Yeah, let's try troubleshooting it by relaunching reconnecting with our public server. This could help. Shall we give that a go? Connect. Fingers crossed. Okay, so let us again copy the private IP address for our private server. Interesting. Very, very interesting. Let's do a ping again to our private server's IP address. It's still not working. What's going on here? We have, let's try check out. What could we check out? I'm wondering whether the CIDR block is correct. But actually, our private network ACL is already allowing in all kinds of ICMP traffic. And yeah, we have Abdul saying, let's allow network ACLs associated with the subnet's ICMP traffic in both directions. Yeah, that sounds great. So outbound rules, let's allow out all kinds of traffic as well. Let's save those changes. And then, yeah, should we do that for the public network ACL too? It's already allowing out all traffic. It's already allowing in all kinds of traffic. So actually, we don't need to touch the public network ACL. Oh, Abdul, look at that. Do you see? Oh my gosh, that was crazy, wasn't it? I'm just gonna drink my water as we absorb that information for a second. Can we all celebrate in the chat? I think we just resolved that issue together. That was so cool. Thank you so much, Calzo, for saying need to add route and route table. That honestly could have been the next step if we still hadn't resolved it. But look at that, we resolved it now. That was awesome. What just happened was we followed Abdul's genius advice, because Abdul in the chat mentioned, shall we allow out network? So shall we, in our private subnets network ACL, also allow out all kinds of ICMP traffic? The moment we edited that, without a hitch, we're getting ping replies now. So what that meant is, previously the issue was the fact that messages could be sent because all the inbound settings were right, but then outbound settings, we needed to make it allow to all destinations. We need to allow that. So before then, there was an issue with the outbound rules that made any kind of reply from our private server not reach back to the public server. So it was kind of like saying your message reached the private server, but the replies from your private server couldn't reach your public server. So the messages couldn't come back out. Wow, look at that. Look at all of these ping messages updating like second by second now. Yeah, Abdul says, wow, I'm so happy. Isn't this so cool? Look at that. You've just saved us, man. Thank you so much. Akil says it works automatically like a king. Yeah, it really did. Aren't we curious? Like, why did that not work? Why did that not work? I feel like, shall we see whether the ping messages will stop? Just out of curiosity, shall we just see whether the ping messages will stop if we put the CIDR block back in? Okay, so let's copy the CIDR block. Let's paste it as the outbound rule destination for our private network ACL. Let's save that. Look at that, the ping messages stopped right away. The ping replies, sorry. We stopped getting replies the moment we put the outbound rules back, put this back into the outbound rules destination field. So there was definitely an issue here with putting 10.0.0.0/24 as the destination for our ICMP traffic. What could the reason be? Could it be that ICMP traffic leaving our private network ACL is actually reaching another destination that's outside of this CIDR block? Maybe. Perhaps. We're gonna take one quick break into looking at the subnet that we have set up for the public subnet and just check what was the CIDR block associated with this. Interesting. The IPv4 CIDR block for this wasn't /24, it was /20. That could be the reason. I think I made a mistake when I was first setting up the VPC. We were supposed to change each subnet's CIDR block into something that ended with /24. I think I completely missed that step back when we were setting up the VPC in like step 1. It was supposed to end with /24, but instead my IPv4 CIDR block for the public subnet ends in a /20. That could totally be the reason. Let us go back into our network ACLs for the network ACL rules for the private NACL. Click on Edit Outbound Rules, and then paste it in here, /20. Save your changes, and then did the ping messages come back? Yeah, they come back live right away. Yeah, so that was an issue that stemmed all the way from when we set up our VPC at the start. We had forgotten to use /24 instead of /20 when we set up the subnet. And because of that, our network ACLs were much more constricted because /24 was a smaller range of IP addresses than /20. We were basically saying our subnet could have this many IP addresses, but then our private network ACL was like this small, like it was much smaller. So because of that, what it let out when it was /24 was much less than perhaps what was the entire range of our public subnet. Wow, that was very, very interesting. I'm so glad we went into that error actually, because that was very good learning to have. So with that being said, let us make sure that our inbound rules again is set up to how it was going to be. It was supposed to only let in all traffic coming from the public subnet as well. And let's fix our security group so it's back to what it was. So the private security group is only supposed to let in all traffic from the public security group. So let us set that up again. And let us make sure that now the security group again is just letting in only ICMP traffic coming from the public security group. Let us find it. The public security group. Nice. Save those rules. I'm so happy. I'm so happy that happened. Thank you so much to everyone in the chat for putting our heads together, suggesting solutions. A special shout out to Abdul for suggesting that we sort out the outbound NACL rules as well, because that's what helped us solve it. And it's good to just reinstate all of these settings back to how it should be. And again, ICMP traffic, even though we've reinstated the settings back to how it should be, it's good to see that the ping messages are still being sent. So we can go back to where we left off with the project. Fubara says, lol, this was such an enlightening moment. Great piece of troubleshooting. I agree, Fubara. I agree. It's different for it to be happening in a YouTube live too, and to be doing it all together with everyone. That felt really, really good. That was really nice. Okay. So we have lots of new lines coming through in the terminal. We are getting the ping replies now. And look at this. Line after line after line of replies. It is looking very healthy. A great indication that connectivity is looking good. If you're curious about what each line means, we can even break into that. So there is a time here, and time represents the time in milliseconds that it took for the ping message to travel to your server and also back, travel to the private server and back. And then there's also time to live. So this value TTL indicates the lifespan of the data packet. So Once TTL reaches 0, this data packet containing this ping message is automatically dropped from the network, and this ping message is automatically just canceled. TTLs honestly exists just to make sure that ping messages you send has an expiry date, so there's no ping messages that's just being sent like into infinity of time. So just a default thing to have. But what I find really interesting actually is the sequence number. So that's ICMP SEQ here in each line. You will see that this number just keeps going up. And it basically just means this is data packet number 612, data packet number 613, 614, 615. So if you ever see that a number is skipped, that means there's a data packet that was lost. If you ever see, if we were to scroll back up to the time when we blocked data packets from running for a little bit, you would see a break in the numbers for the data packet. I wonder where it is. But another example is the fact that our data packets only started from 59, because initially ping traffic connectivity wasn't successful between our two servers, which is why it didn't start from ICMP sequence 0, it started from 59, because it took until the 59th data packet for the connectivity, for us to sort out the connectivity and for the messages to work. So, whew, that was cool. That was really, really cool. Let's take a quick screenshot of the successful responses, and let's move on to the last step. Wow, that was so much fun. That was so much fun. So I'm going to take that screenshot now. Boop. Let's take that screenshot. And then we're going to answer a few questions. So first question, what is ping and why did you use it? So ping is, good prompt. Ping is ... I use ping to, what do we use ping for today? So ping is a tool to test the connectivity between two servers. To test the connectivity between two servers and also the response times, i.e. the performance of the connection. I used ping to test the connectivity between my public and private servers. Very good. All done. Next, what was the ping command you ran? The ping command I ran was ping, and then followed by, we're going to scroll a little bit up here, but followed by the private, I almost said public, the private IPv4 address for our private server. So the ping command I ran was ping 10.0.143.198, which where this is the private IPv4 address of my private server. What did the first ping return? What does it mean? Ooh, good question. The first ping returned no replies from the private server. This meant security settings with my private server was blocking ICMP traffic, was blocking inbound and or outbound ICMP traffic, which is the traffic type of ping messages. So that is a, Okay, perfect. The first ping returned no replies from the private server. This meant security settings with my private server was blocking inbound and or outbound ICMP traffic, which is traffic type of ping messages. Nice. Last question. How did you resolve this error? Well, we did many things, didn't we? Many things because we also had a someone made the issue of defining a subnet with the incorrect IPv4 side block. That person was me, but that's okay. How do we resolve this error? I troubleshooted this by enabling ICMP traffic in my private server's network ACL and security groups. Nice. Cool. As a bonus, I also made sure the source I defined correctly pointed to my public subnet. I defined in my network ACL correctly pointed to my public subnet. I'm going to say brackets, thanks Abdul for the tip. All right, so how do we resolve the error? I troubleshooted this by enabling ICMP traffic in my private service network ACLs and security group rules. As a bonus, I also made sure that the source I defined in my network ACL correctly pointed to the public subnet. Thanks, Abdul, for the tip. All right, done. That looks good. Let us move on and do the final connectivity test for today, which is to test VPC connectivity with the internet. So since your public route table has a route from the public subnet to an internet gateway, this sentence is coming with a bit of assumed context. So if you're feeling like, oh my gosh, what is going on here? Don't forget that when we set up our VPC, a public route table was created. And this public route table is pretty much the middleman between your public subnet, this thing over here, and the wider internet, the outside world. So since this route has been set up, your public subnet can now, traffic from your public subnet can now travel to the internet gateway and reach the public internet. We need to test that. Let's verify that that works. So we are going to be using a different command now. So scroll down and you'll notice that ping is still going hard at it, getting ping replies from our private server. So thank you so much to ping for working tirelessly for us. But we can now give ping a rest. To quit this test, the second connectivity test that we have, all you have to do is click Control-C on your keyboard. Done. So ping has even given us statistics. It's saying 1,072 packets were sent to your private server and 893 were received back. It even calculated that around 16.7% of the messages that were sent to your private server was lost. So that was very, very cool. Anyway, we're now moving on to test that connectivity between your public server to the internet. So we're going to do something new. We're going to enter a new command, this time called curl, and we're going to do curl example.com. So let us put that into the terminal and let's run curl. Whoa, look at this response. What is going on here? So we have a lot of lines of data coming back to us, and as we look closer, we're like, oh, the data that was returned to us is in HTML. Do you see how, if we were to scroll, this is the command we put through, curlexample.com, and look, the first line in the replies says document HTML. So the reply is in HTML, and we are actually seeing the HTML of a page. It is actually defining an entire web page. So if you want to copy this HTML put it in an HTML file and run that file, you will load up literally a website's HTML content. So this is interesting. We just retrieved some data from somewhere. We just retrieved HTML data from somewhere. So what was going on here? Curl, just like ping, is a tool that we can use to test connectivity. And in this case, we are testing it to see whether from our public server, don't forget that whenever we're in this this black screen, or whenever we're in EC2 Instance Connect, we're kind of using or communicating directly with our public server. And then from our public server, we ran curl, and curl not only checks connectivity with another server, but it also retrieves data. So when we ran curlexample.com, that command sent a request to the server that's running example.com and said, hey, can you give me your HTML data? So that request was retrieving HTML content of the website that you entered. So the website server processes your request and it sends that HTML data back, and then that data would have been put into a data packet, and that data packet just traveled back to your EC2 instance, and now your public server is giving you this response. Awesome. So your curl command has outputted some great data, and what you're seeing is some raw HTML. It's a great success. It is proof that from your public server, you can go out into the internet and retrieve data from other public servers. Wasn't that so cool? Let's have a bit more fun with using curl, and now let's run something different. Let's run curl nextwork.org. Enter. Interesting response. We ran curl nextwork.org and we're only getting a single line now. The single line just gives us anchor href. So anchor is a tag in HTML that basically says link to, and it says link to this specific link. And it says found. That's it. That's all we're getting as a response back. Now, this isn't what the NextWork website looks like, does it? If I were to just visit the nextwork.org website from a new tab, this is what the NextWork website looks like. It's not just a single link that says found. So there's something fishy going on here. Why do we get that one line response? So this is an extra bit for us to learn. Typically an output called found just means that the website at the URL you've entered, it's moved to a new URL. Nextwork.org is not the final URL for the website that you're wanting to visit. So it's basically saying nextwork.org does take you somewhere, but it takes you to somewhere that's beyond nextwork.org. It redirects you to another URL. So at nextwork.org, this URL itself, it doesn't actually have its own HTML content. All it does is it redirects you to another link that does have HTML content. So so we can actually verify that again in your browser. If you want to run curl nextwork.org, look at what is the URL that ends up on your browser. Is it just nextwork.org that ends up on your browser? No, the URL we get directed to is learn.nextwork.org/project/blah blah 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 blah. So it's actually a very, very long URL that sits behind nextwork.org. And that's why curl is saying, hey, look, there's no actual HTML content sitting at nextwork.org, but there is HTML content sitting at the URL that nextwork.org points you to, this URL. So it even gives you the link here that tells you how you can visit that final URL it redirects you to. And let's run curl with that URL. So I'm going to copy the link that was inside the response. And what you can do now is run curl and paste. So now you're running curl on the URL that the first response has given you. Whoa, look at that. Now we're getting a lot of HTML content. There we go. Perfect. That was a successful run. So what that meant is, just like the previous example with using curlexample.com, curl has now fetched complete HTML content of this specific page, and it's given it back to you. So cool. So cool. It's so cool to see NextWork's first project in HTML format just within your EC2 instance's terminal. It's just so powerful, you know, the things you could do with ping, with curl, all of these cool commands. So let's take a screenshot of this response and let's fill in the documentation. All right, we're gonna upload our screenshot and then let's say, what is curl? Curl is a connectivity tool that not only tests, I would say, actually, let's reword it. Curl is a connectivity tool that tests connectivity from a server to another server and retrieves data from the target server too. I use curl to test the connectivity between, very cool. So I use curl to test the connectivity between my network's public server with the public internet. Okay. I think it's also a good shout to say my public server would only actually, let's rework this again and let's say this test would only be successful if my internet gateway, network ACLs, security groups, and route tables were set up correctly. That's absolutely true. I mean, let's just look at the architecture diagram and you're gonna notice, oh my goodness, in this connection between your public server and the public internet, there's already, you know, a security group that needs to get through, a public sub that needs to get through, public network ACLs, public route table, internet gateway, and then out to the internet. There's also, of course, the VPC right here. If any of these settings were incorrect, I don't think that connection would have been successful. So, absolutely, the fact that these connections were successful is a testament to your good work and setting up your VPC, or you're setting up your network in the right way. Cool. So next, how are ping and curl different? So ping and curl are different because they return different responses to my public server's terminal. Ping responds with a report on the performance of connectivity with my private server. Curl responded with HTML data from another public server. So that was really interesting. It's cool to see the different kinds of responses you could get based on the different connectivity tools that you use. All right, next, what was a successful curl command you ran? I ran the curl command, which returned, okay, perfect. So I ran the curl command, what was the successful one? Curl, and then there's this long link here. I ran the curl command, which returned the HTML data, HTML content, actually, of NextWork NextWork's first project guide. Cool. I think we're all done. So let's click done at the bottom here. Congratulations! That was a massive success in testing your VPC's connectivity in 3 different ways. From you to your public server, from your public server to the private server, and finally from the public server to the external internet. So that was very successful. And you've completed today's project, setting up your very own VPC and testing connectivity. That was huge, wasn't it? In last week's project demo, we said that super cool was something that Amber really likes to say. Amber is the CEO of NextWork. Something else to learn is our engineer Krishna loves to say, huge, that's huge. And I think that absolutely applies to this project. That was huge, and we've made it to the end. Isn't that so cool? Let's answer a few questions to wrap things up. And then we're going to see our documentation. We're going to delete our resources. We're also going to share our work. What is Amazon VPC and why is it useful? Amazon VPC is AWS's foundational networking service. Having VPCs is the reason why our resources can be made private or public to the internet. We also set up our own traffic flow, security rules, our own networks, traffic flow and security rules within using a VPC. All right, next. How did you use Amazon VPC in today's project? In today's project, we used Amazon VPC to set up a VPC structure, or to set up a VPC and its components using the VPC wizard, and then launched EC2 instances and tested the connectivity between my network's resources. What is one thing you didn't expect in this project? Ooh. Shall we talk about the error that we ran into? I feel like that's a pretty good one. We didn't expect to run into an error due to a network ACL's source. Pointing to an incorrect. What was the thing that was called? It was called an incorrect subnet CIDR block. This was a great reminder of the importance to slow down and double check configuration settings when using the VPC wizard to automate tasks, or to automate creating the VPC. We didn't expect to run into an error. We didn't expect for a network ACL source to point to an incorrect subnet CIDR block. This was a great reminder of the importance. This was a great reminder of the importance of slowing down and double checking configuration settings when using the VPC wizard to automate creating the VPC. I feel like if I wasn't using the VPC wizard, there would be a lower chance of the wrong CIDR block being used. I have a gut feeling. So it really goes to show that this is the reason why we don't use things like VPC wizards from Project 1, that we only use that in later on in the project series, because using it at the start, first things first, it'll be a lot harder for you to really understand the reason why there are different components in a VPC. Reason number 2, you can easily make mistakes like what I've just done. The funny thing is, things like VPC wizards exist to help us with making things like VPCs very, very quickly. But absolutely, if you have very, very specific settings, sometimes it is better, in my opinion, to slow down and do things bit by bit to really make sure you've covered your bases. Although next time I'll absolutely still opt for using a VPC wizard, except next time I'll be a lot more careful. All right. We also have Calzol saying, may I know what is the correct CIDR block? Yeah, of course. We talked about this earlier in the project when we were troubleshooting, but what was the issue was I had the CIDR block that said 10.0.0.0 slash 24 in, yeah, it was slash 24 in the private network ACL's outbound rules. So the private network ACL's outbound rules was only letting out traffic to this source, 10.0.0.0 slash 24. But the correct the correct CIDR block would have been 10.0.0.0 slash not 24 but 20, which is a bigger range of CIDR blocks. So I hope that helps. And if you're wanting to get a more detailed breakdown of what was going on in that error, absolutely, I'd highly recommend that we revisit that error that's like further up in this exact video. You don't need to click away. Maybe just like scroll up a little bit and you'll be able to see the error when we ran into that too. But yeah, thank you so much for that. Fubara also says, lol, the error was made when your console logged you out and you had to rush the VPC configuration again and you missed setting the subnet CIDR block. Oh yeah, I did get logged out and it caused the VPC configuration to be rushed. Well done, Natasha, such a great host. Thank you, Fuvara. Thank you so much. That was so sweet. Wow. Completely would have missed that myself. Can't believe that happened today. How much time did this project take you? Embarrassing. That this project we definitely beat the 1 hour 1 hour expectation. And this project took me 2 hours and 45 minutes, including live demo time. And troubleshooting an unexpected error. Thank you to everyone in the live demo for sorting out the issue together. Done. Oh, let's go down. Done. Now it's complete. So cool. Before we dive into the steps for deleting our resources for today, now that we've done our reflection for the project, you can absolutely challenge yourself to delete everything that we created in this project on your own. What I'm going to do first is it's always good to delete EC2 instances first, because EC2 instances, when they're running in the background, absolutely could be a killer, to be honest, for your in terms of AWS bills, in terms of any charges that could rack up. If you weren't familiar yet, the the AWS free tier lets us use EC2 instances for free for the first 750 hours every single month. So once we exceed 750 hours, we absolutely get charged for an EC2 instance. So we want to make sure that we terminate those instances. And yeah, let's click on terminate there. It usually takes about a minute or two for it to terminate. So we'll just let it terminate itself for a little bit. In the meantime, I am really loving the chat. Thank you so much, Kelso, for saying thanks, Natasha. Plexidus for saying awesome. Thank you, Plexidus. And Joe says, I did not help sort out the issue, but I can say I was here for it. Yeah, you were, Joe. Yeah, you were. And who said you weren't here to sort out the issue? Your vibe in this live always makes the biggest difference. So thank you so much. Andre says, is this proprietary documentation software? Yes, this is documentation software that we've created ourselves in-house. A big shout out to Krishna Kapadia and Krishna Kaudas, our two wonderful engineers, for developing this software. Of course, a big shout out as well to our engineer John, as well as Amber and the team, for being amazing designers and amazing brains behind this software too. Let us refresh our instances. All right, it's been terminated. So our EC2 instances successfully. Let us go into our VPC and delete our VPC. So let's visit the VPC console, click on your VPCs, and can we find it? NextWork VPC, that's it. Let us delete it. Awesome. All we have to do is click delete here and let it delete everything attached to the VPC. All right, it's taken its, that was very fast, deleting everything. And let's just double check everything is gone now by clicking into the different pages within your VPC and refreshing things. Perfect, gone. Let's check the route tables, gone. Oof, internet gateways, gone. My goodness. Network ACLs is gone. Yes, it is. Security groups. Refresh that. Oh, Ashish, thank you for commenting. Where can we get the documentation which you're using? You can find it by clicking on the link in the description box. I know, Ashish, that you're also part of the NextWork community now, which is awesome. And you can always find our latest project in the community. If you were to visit all AWS projects on the left-hand navigation panel, and then when you scroll down here, you can see that the latest project is here, Testing VPC Connectivity, Project 16. Cool. All right, so we're just gonna make sure, oh, this is an old tab, we don't need that. We're just gonna make sure that all of the security groups as well are gone. Nice. And then I'm pretty sure we checked the network ACLs. Yep, they're all gone. So just like that, we've deleted all of the resources for today's project. That was very fast, all thanks to the VPC being connected to all of these different components. So the moment you delete the VPC, you delete everything that's connected to it and inside of it as well. And now it's time to share your project. Let us do this by scrolling all the way down, and you're going to see that there's a blue Mission Accomplished button. Click on that, and you have the option to share it on LinkedIn. So let's click on share on LinkedIn. Woohoo! Look at this. There's already a LinkedIn post that's populated for you that you can use to just click post, and right away you're sharing your learnings for this project. But what you could do, and by the way, make sure that you double click on NextWork here, or you just add a new @ in front of NextWork here to tag NextWork so that your post can reach more people. And you can also click on view documentation, that second link. And look at that. All of your screenshots and all of the work that you've submitted today organized neatly in a documentation for you. So this is awesome. It is a great summary of all of your learnings, everything that you've written, the screenshots you've uploaded. And this documentation absolutely can live in a portfolio. It can absolutely be linked within your resume, you can have a resume line that says completed this project and link that line to this to show any recruiter or anyone viewing your resume the documentation behind that work. And yeah, uh, it looks beautiful. Super, super exciting. I can't wait to see everyone's documentation as well. I love that Akil says, awesome session, Natasha, enjoyed it. I am just worried when I'm gonna use similar documentation lines now. I'm not gonna tell on anyone. I'm not gonna tell on anyone if you use similar documentation lines. Absolutely. The funnest way to write documentation originally is probably to, instead of typing it out, try to say out loud how you would explain it to someone else. And the moment you say it out loud, you're truly putting things in your own words sometimes. Like look away from the screen, look at something random, maybe this plot that's in front of you, and then just try to explain to that plot like what you've just learned. Saying it out loud makes a big difference. And I think it's the reason why when I write documentation in a YouTube live, it actually sounds and feels different to if I were to write my documentation on my own, quiet, headphones on, just typing. The moment you say things out loud, you're really just putting it into your own words now. It's a different feeling. And yeah, documentation looks good. You can click here to download your document. So once you click on that blue banner, save it as a PDF. Now, when you're saving it as a PDF, make sure you're clicking on more settings here. And the paper size is A4. Please don't do like an A2. You'll notice that your page size is going to start looking a little different. Don't use tabloid. Maybe tabloid could work. Yeah, no, it doesn't. It really doesn't work. Look at how the pages start getting broken up if you use the wrong page size. If you use the wrong paper size. So make sure you're using A4 as your paper size. And then make sure headers and footers is unchecked. You know, if you have headers and footers checked, you know, you get these lines at the top and bottom of every single page. But actually, you can uncheck it to keep your page super clean. Now it looks much better. And then you can click save. Make sure the destination is save as PDF instead of any printer. We just want to save it as a PDF. Click on save, and then let's just say, add your name to it. And then, now that you're here in your LinkedIn post, you can add a document like this. So let's click on, oh, I don't think that was the exact file. So let's choose the right file. Choose the documentation you've just downloaded. Give it a nice name, testing VPC Connectivity, like this. And once it's uploaded, might take its sweet time. I don't see the done button. Okay, once it's uploaded, you're definitely ready to click post now, because now your post also has a PDF document with all of your handy work from this project today. I love this so much. I love seeing everyone's documentation posts. It really makes our day. So thank you so much to everyone for always posting, always sharing, celebrating on your project completes. It's awesome. Yeah. Wow, this is so cool. Thanks for the feedback, everyone. Abdul says thanks for the session. Educating and challenging. Jerome says the session was awesome. Thanks. Bushan says, can you send the documentation link here also? Yeah, of course we can. So here is the project step-by-step guide. Here's the link to that in the chat now. I hope that helps, Bushan. And we also have, Dylan says, thanks so much, you're the best. Thank you, Dylan. That's so kind. That's very, very kind. Plaxides also says thanks. Abhishek says thanks for the detailed session. Wendy says shot Uso. Shot Uso back to you. Joe says, awesome session, Nat. A great distraction from debugging my students' code. Now I have to get back to it. You're a vibe, Joe. All the best with debugging your students' code. That sounds like a mission in itself. Andre says thank you as always. Wendy, I'll make my post as soon as I finish. I can't wait to see your post, Wendy. And Bushan says thanks. Thank you so much, everyone. That was such a fun session. That was a lot of fun. And I think we're ready to wrap up. Networking Project 5 is done. Today you've learned how to connect to your public server using EC2 Instance Connect. You've learned how to test the connectivity between two servers using ping. You've also learned how to connect test a connection from your public server all the way to the internet using curl. So those were 3 amazing connections, and you did that. We did that together. That was a lot of fun. Bushan says it's not available in app. Next time we can do it through Python SDK. Wow, we're getting a lot of cool requests now. The project step-by-step guide you can definitely still access from the Circle app. You'll just have to visit the NextWork all AWS projects channel in the Circle app, if that's the app that you're thinking about. And Andre says, next time, can we do it through Python SDK? I think that's definitely something that's in the pipeline, in the works. In the meantime, Andre, because we are wanting to keep this very beginner friendly, very visual and straightforward to start with, this networking series is probably going to stick with the management console for now, but we are absolutely thinking about the CLI. We are thinking about Python SDKs. We are thinking about Terraform all the time as ways that you can level up after building the foundations. But yes, thank you so much for the suggestion. We'll take that on. It is wild that all of these learnings from this project packed into one session. We did it in one sitting. All together, guys. That was really cool. Great work. We'll see you in the next project. Thank you so much, everyone, for being such amazing team members to be doing this project with. It really felt like we were doing this entire project together. And I can't wait to see everyone's documentation. Please make sure you post them, share them with us, share them on LinkedIn. It's always fun to see each other's wins. And again, a big shout out to everyone for troubleshooting that big error together. I don't think we would have been able to complete that project if it wasn't for everyone's help. So, all right. Yes, Andre, do suggest that in the community. And Bushan asks, can we get load balancing and auto scaling with S3 versioning? That's in the pipeline too. You'll see that project soon. Michael Winton says, one sitting? Crazy good. My goodness, Michael. It's so good to see you here. What a surprise. Wow, that made my night. Thank you so much. Akil says, have a good day. Sridhar says, thanks. I'm excited to do the next project. Me too. Very, very excited about the next project too. Okay, guys, this is where we're going to wrap up now. We'll see you in the next project. Have fun. We'll stay in touch in the community in the meantime. And it has been an awesome time. Bushan says, have a good day. Bushan says, nice session. Bushan says, nice concept clearing session. Thank you for the compliments. All right. See you next time. Bye for now. And hope you enjoyed the project. See ya. Bye.